Okay, one more speaker to go, and we will be towards the end of the day there. So joining us, last but certainly not least, we're going to be talking about designing sustainable APIs. We've got Adrien Nortain. Adrien is the CTO of Zenika. And I think I'm super excited because we've heard and seen a lot of people building the APIs, and I think sustaining is always a harder part of it. So welcome, Adrien, and take it away.
Thank you very much, Hakil. Is everything going right with the sound and everything? Guess so. All right. So thanks everyone for being here. I'm delighted to share this with you. It's a topic that I hold dear in my heart. So today I want to share about designing sustainable APIs. And before we start, I would like to just introduce myself very quickly so that you understand maybe some of my biases, why I'm going to talk about this particular topic. So first and foremost, I'm a husband and father, so sustainability is something that I hold very dear because I always think about my child, right, going forward and the kind of world that we are going to leave to the next generation. I'm a green IT enthusiast. I've been certified in digital, services eco design. So that's kind of a thing that I'm going to develop afterwards, and also in sustainable digital. So it means that I have the correct knowledge to discuss these things. I've been practicing, eco design since 2013 now, 2014, I guess. And I'm an architecture and change consultant at heart. So when I tackle the topic, usually I tend to take a step back and not just engineer things so that they work, but that I want them to work durably. I want them to have some kind of impact. So we're going to develop that aspect as well. Today, I'm the group CTO of Zenika. So I'm heading the technology on technical as well as topics over there. So I'm managing kind of a team in order to make sure that we can deliver the best services out there. All right. Okay, let's start. A disclaimer before we start, because you may have heard that in order to build sustainable services and all, what we need to take care of mainly is the power consumption. I tend to hear that a lot. That okay, what do we measure? Is it just is it just the power efficiency? What I hear as well is designing a sustainable API means that we have to make it very performant. We are going to see that that's not completely true, and we are going to see why. So we're not just going to focus on power efficiency and carbon footprint. That's just a disclaimer right now. Sustainability is not just about optimization. We are not just going to take pre-engineered services and then try to make sure that they're sustainable. We are going to look at the inception phase, because what you will learn is that 75% of the impact you can have in this particular topic is during the inception phase, not the optimization phase. So when you want to optimize the carbon footprint, when you want to reduce the e-waste coming from also your services, your digital services, when you want to look at the kind of resources that you're going to consume, 75% of the impact you can have on all that is before you even start your first line of code, right? It's during inception. We're going to see that. So what is this presentation about? Because we are in the engineering track, and I guess most of you are engineers, right? So I want to speak the same language as well. But we are still going to look at the broader picture right here. When you are going to engineer something, what I would like, but it's just one of my one of my wishes, is that more engineers tend to look at the impact that they can have on the overall ecosystem. So instead of just saying, okay, I'm solving something just for use case, for example, anything that we write and that we publish in production out there actually has an impact on the overall ecosystem. So how do we make sure that this ecosystem is sustainable in itself? We want to have a proactive approach. We don't want to be reactive anymore. I mean, looking at the measures and all is going to give us some feedback on whether we are doing this right or wrong. But we already know, based on all the measures that we have for the past 10 years, what can work and what doesn't really work. And why do we want that? Because lots of APIs in the ecosystem, they end up dying or close. And this has a tremendous impact, on the business itself, because it's costly to maintain, because it's very difficult to use. So you tend to have zombies out there that are still running on servers, APIs that are still running and are barely used. I mean, they have one or two consumers, sometimes they're seldom used, and that is cluttering the overall ecosystem. So let's see how. We have APIs first slowly dying from Conway's law. You might have heard of Conway, right? Conway's law tells you that any structure that you produce is actually a mirror of your communication system. So if you have a team that works well together and they're always working on the same thing, most of the time you'll have some monolith. If you have distributed teams working on many different things at the same time and they integrate, maybe you'll have some kind of microservice architecture. I am really brushing up a very superficial kind of picture right here, because it's actually more complex than that, but you get the idea, right? But the problem is that because of the communication structure and the fact that teams, they rotate a lot, that they don't communicate well, you build a lot of depths, right? APIs that connect to other APIs that are legacy APIs, for example, or you have a legacy structure and you're building on top of it, and things get a bit clanky at first. So at some point, you want your ecosystem to be evolvable, and someone will tell you, oh, I want a new window, for example, over there. And the structure is not here anymore. I mean, it's not possible because you will have to make a lot of different, choices that are going to clutter the system even further. So that's why we need to have a different approach, right? In order to avoid inconsistent or cluttered design, we want to avoid the lack of product or service vision. That happens when all your teams are not aligned on what you are building. And we want to make sure, based on Conway's law, that whenever you produce something, an API that you add to the ecosystem, actually it means something. It has a proper impact and you know exactly what it's going to deliver out there. You want everyone to be aligned on the value that you are going to deliver, and you want them to collaborate, because if they are aligned and if they don't speak to each other, that is going to be reflected in the integration of these APIs. You want to make sure that they're well documented, because at some point, you're not going to be in the same team forever. You're not going to support these APIs forever as well, but we want them to be as durable, to last as long as possible. We want to make sure, that for the ecosystem to be sustainable, that whatever we add over there doesn't rotate too often, right? Because it needs to add value for a certain time. Okay, we have some APIs, so not well designed, and that's the first thing, right, that clutters the overall ecosystem. Now I'm going to talk about another issue that may resonate a bit more with you, is the fact that most of the APIs out there, they are also running on tech that may be obsolete in a couple of years, right? And I'm going to demonstrate that based on all the APIs that we've been building for the past 15 years. You may have heard of these technologies right here that are already outdated completely. I don't know if you remember when we also worked with Flex Technologies. We used the AMF servers or lifecycle data services. And it was terrific at the time because we were, publishing these APIs that were really fast, sending binaries over the network, and it was just directly consumed by our clients, and it was perfect. But now it's completely obsolete. Nobody uses that anymore. We had this era where everything was about soap whistle, and it's still used, to be honest. But we see more and more consumers, API consumers, they don't want to consume these APIs anymore. They're really going the simpler way, right, with REST services and RESTful services. We used to, have all these XML packages as well. We are tending to move away from that. And when we had this old Java ecosystem thingy back then, RMI was a thing. Today it's not here anymore, but this was how we were doing remote procedure calls. That was with RMI back then. We still have zombie technologies, meaning that they're not completely dead, but we still have to manage them in big companies and all. And these are the mainframe technologies, right? They're nowhere near to be extinct, but they're still zombie-like. And we also have, the big Java servers that are still running out there, running a lot of business services, and we need to connect them. So we have to be careful in our design choices for the next, deployments that we want to have in the future, because all of this, you might think, oh yeah, we're not going to repeat the same mistakes, right? Because what we work with are modern technologies. Well, what if I tell you that everything that I've been talking about in this particular slide, they used to be modern as well. And the issue now is that they are not anymore. So you might have to consider that whatever you're working on right now, and it seems fancy and all, like Kafka and such, at some point it may be obsolete. So what is the level of adherence that you are proposing right here, right now, with the technologies that you're deploying? You might want to think about that. And you might want to think what the cost is to keep all these APIs alive, right? The ones that are running on old technologies, the ones that are not properly, designed, and it's a bit clunky to use them. Most of the time, we are going to use anti-corruption layers, and that's the allegory, right? You are Rick in this modern world, and you want to survive, and you want to interact with the legacy world, but the problem is that it's full of zombies, and you want to have this anti-corruption layer and not get beaten, right? Not get corrupted. And you want to work with that. The problem is that um, zombie servers, for example, was a study from 2015, 2016, and you're going to tell me that it's a bit old, but that's the only numbers that we have today. I think it was from a Puppet. Um, a study says that around 30% of the servers are running services, public or publicly accessible services, that are seldom used. Seldom used means that they're maybe queried once per day, top. And but what it tells you is that 30% of the overall ecosystem is consuming power without really delivering any value. So at least we got 70% right. That is okay. But even in this 70%, we are going to see that some of them are not well designed, and there's going to be a rotation. Most of them are going to die, and we're going to replace it, and maybe they will fall into the zombie category as well. Okay, so maybe I should stop creating zombies. That's what Rick is telling himself. He should maybe stop killing people as well. Okay, testing for API diseases. What's an API disease? An API disease is something that will slowly lead the API that you're designing to a zombie state. And you want to avoid that, right, for sustainability. So you might want to ask yourself, in order to diagnose, right, your APIs, do I have maybe a lack of vision in my API? Do I have a lack of coherence or lack of records? If I have a lack of these things, maybe the value that I deliver out there is not properly identified. So maybe the value I deliver is not that, at the level that I want it to be. And it will slowly decay as well. Do I have a hard tech dependency? Do I have a hard coupling with other APIs that may be legacy APIs one day? Do I use non-standard protocols because I think they're fancy today, or maybe they're really performant, or I think that they solve my issues today, but maybe in the future they will just be legacy as well? So do I have maybe a lack of renewability in my overall ecosystem? You might want to ask yourself as well, is my API or the interface that I put out there, is it under use? Do you have the right metrics to measure that? Do I have under use servers as well? Meaning that, okay, your API is well used, but maybe the overall infrastructure that you're running it on is not that optimized, meaning that you have either over-engineered it, or you are not running it, on the cloud or with shared infrastructure system. Maybe at some point you want to ask yourself, um, is it well tailored, right, for the service that I deliver? Do you have an underused service? So apart from the interface or the API, so the technical part that you're exposing, what about the business service, the underlying business service? Is it underused? Do you think that it should be more used? In that case, maybe the overall interface or the documentation or the manual or the popularity of it is not at the level that you want it to be. So you have to be careful because this will impact the cost of maintaining your APIs in there. Okay, whatever we do, once we diagnose all that, is to avoid the decay of our API, right? So it's good that you ask yourself these questions as soon as possible. Of course, if it's already too late, you have deployed some things, you can always, do a bit of self-introspection. But whenever you are designing new APIs that you want to get out there, these are the three categories of questions that you want to ask yourself in order to avoid early diseases. And because I've been very negative for the first part of this presentation, and I apologize for that, I want everyone to take a moment and just take a big breath out there. Okay, moving on. Now we're going to talk about sustainability itself, because I've talked about all the problems of the APIs, the zombie APIs, the fact that we have an ecosystem that we don't want to clutter. So I was a bit alarming, but let's focus on the solution now. What is sustainability? Sustainability is at the crossroad of many different things. So we are going to aim for a social impact in our APIs. Whatever you deliver out there, it's for users, for certain users. And you want to make sure that it's going to help them in some ways, that it's going to help their life, it's going to help their work, and you're going to have happy users. Once you have that and on your side, it makes sense for your business. You have something that is equitable, meaning that you deliver a service out there and it's well received. Most of the time, when you have that, you find balance and you're happy with that. But that's not enough for sustainability. I'm going to talk a bit about the environmental impact of APIs. Environmental impact means that whenever you produce an API out there, it's going to use server resources. A server, even if you deploy it on the cloud, it's going to use power. That's the thing that you might be very well aware of, but it will also need a lot of manufacturing resources. Do you know how many different kinds of metals or resources or abiotic resources it's going to use? I'm not sure you do. And the fact is that whenever you take space in a data center, you're taking more space for someone else. So whenever a data center wants to welcome more services, of course, it can just shut down some of them. But most of the time, because your APIs are running, 24 hours, seven days a week, you need to have new racks and create new servers, manufacture new servers as well, physical ones, physical hardwares. And the problem with that is that has the most impact on the planet. You might want to know that 2/3 of the environmental impact you can have is on the pre-manufacturing and manufacturing phase of the hardware. It's not during the run phase of your APIs, right? So power consumption, even if you see a lot of, okay, we want to be carbon zero by 2025 and such, actually that will not have, the best impact on sustainability. The best impact that you can have is, do I really need my API out there? Once you know that you can run your API on a hardware that is already existing, so you can improve reusability of the hardware, that you can improve the efficiency also of the usage of the hardware. That's where you can have the best environmental impact. If you need to build new hardware to run your APIs, you're going to have a tremendous environmental impact that you are going to manage. So once you add the environmental impact, if it makes sense for the business, you have a viable option. It might not help the consumers that much, but at least you have something that makes money, and at the same time, you are not impacting the environment too much. You are reusing as much hardware as possible. You are not aiming for people to renew their mobile devices that much, which has a tremendous impact on the planet, and you're viable. But we, as consumers, we want things to be towards us, right? So we want livable options. We want things to not have a meaningful impact on the environment, but we want them to be useful in our everyday lives. And we don't really care about the business impact, right? But once you have a balance between all three of that, that's where we aim for sustainability. And that's what you should be aiming for. You should be sure that when you engineer something, that's something of value and is going to be of value for your users. You have to be careful about the cost efficiency you have. It has to be beneficial, right, for your business. So you have to see how much it's going to cost you to maintain these APIs and what will be the revenue for it. On the other hand, you have to look at the resources renewability. How much of the hardware can you reuse? How much of the old code can you reuse? How much of the legacy system are you building in there and you are going to need rewriting? Development phase takes a lot of resources as well, because you will need developers, you will need to upskill them, so they will need laptops as well, they will need to install new things, and they may need the latest laptops also to develop your APIs. So you have to be careful about that. And you enter the architecture realm, right? You're not just engineering solutions anymore, and you have to think about the bigger picture for a moment. You have to be careful, because if it's just cost efficient and you have a resources renewability, you might have a useless API, but it's still viable. And you have to be careful, because if you have just a value delivery on resources renewability, it might be costly and not sustainable anymore. So you want to aim for sustainability right here. Okay, but you're going to tell me, I don't really care about my sustainability API, right? I want to make money. I want to have time to market. I want my APIs to scale and all. And this is also the topic, right, for this conference right here, is designing and digitizing APIs at scale. So why am I even talking about sustainability? Shouldn't I be talking about flexibility of the API ecosystem, availability, performance, and such? Okay, flexibility is all about how fast can you change the implementation. So when you are implementing APIs at scale, you want to make sure that you can change the components very fast, right? Because it's still going to grow. So you want to make sure that you're not going to be stopped at some point or blocked. Evolvability of the system, how fast can you deliver a new feature? We've seen with the Conway's law, the problem with unsustainable ecosystem is that it's more and more difficult to publish something out there that is going to be of value or that is going to work very well with the overall ecosystem. So you want it to be evolvable. And last but not least, you want your ecosystem to be performant. You want things to be efficient and delivered fast. Hey, Hakil, welcome back.
Hi, Adrian. We are almost out of time, mate. So if you can just take the next 30 seconds to wrap up, that would be great.
I will do. All right, never mind.
Okay.
So we want to ensure a lot of things. We want to ensure not cluttering the system. Okay, that's one of the things that you want. You want to control the growth of your system. You also want to make sure when you're designing APIs that you have a vision for the overall coherence. So you want to be impact driven in order for them to be useful. You want them to be reusable, your APIs. So you want to do a bit of domain driven design. And you want to make sure that you meet the expectations. So set the SLA, SLO, SLI correctly. Last but not least, from the words of Chris Richardson, you want your interfaces to be very simple. So you want to use Yagni, you ain't gonna need it. So whenever you publish an API, be sure that you're gonna need it. You want to use KISS as a mantra, so keep it sustainably simple, your interfaces, and you want them to be self-describing, of course. Be very aware of your hardware and runtime for both server and clients, because as I told you, that's where you're going to have the most impact. Okay, one deployment doesn't fit all. Okay, I'm not going to talk about that because we don't have time anymore, but maybe during the questions Q&A, I'm going to go back on that. But lifecycle assessments are really good for API services and business services you want to compare two different solutions. So my conclusion, quickly, 10 seconds. All right. If as an engineer you focus on the fact that your API is recyclable, is simple enough, and is purposeful, most of the time you will have all that you want in order to design at scale. You will have the flexibility of your ecosystem, evolvability, and performance. What you need as a thin layer, integrating these two is engineering mindset. You want to, adopt all these things at the bottom in order to make sure that you get everything at the top. And that's it. Sustainability, less about reacting to matrix or mastering technology, as I told you earlier, mainly about the design. Thank you.
Well, I have to say that this went down a very fascinating path, a very exciting and exciting path, but not at all what I thought you were going to talk about. So thank you very much for that. Yeah, definitely gave my mind a bit of a workout. So thank you. We have unfortunately run out of time, so there's no time for Q&A. But again, just a fascinating presentation. Thank you very much, Adrien.
Thank you.